Right, welcome to this tutorial, and in this video we're gonna be talking about um, second order partial derivatives and mixed partials. Second order partial derivatives and mixed partials is gonna be the focus for this video. So what are we trying to establish here? So we see now that we've had a ground on the first order partial derivatives. Now we move on to the second order, which looks something like this, like this, like this. And also these can be denoted as f of xx, f of yy, f of xy, and f of yx. But further, they're telling us to show that the mixed partials are what are equal. So showing that the mixed partials, which is this one and this one, that this will always be equal. These are equal. So, and that is just the Clauret's theorem to show that they are what they are equal. So we're just going to do question A here in order to establish these concepts which are being talked about here. So f of x, y has been given to be 3 to the e, that is x, then y raised to the power 3 like that. Okay, so now they've given it like this, and we have to find the second order partial derivatives. Of course, to find the second order partial derivatives, meaning you need to find the first order partial derivatives. So meaning we first have to find f of x and fy. Fx and fy is what we have to find first. So fx, meaning we're taking the partial respect to x. So meaning we're treating y as a constant and just differentiating what x. So you see where x is, it's here. So differentiating this, I still remain with what? With the same thing here. Of course, multiplied by the 3. So I'll get e to the x to the y to the power 3. Then I have to differentiate what is in my uh, in my power, in my exponent. I have to differentiate what is in the power there, and of course with respect to x. So I see I just have x to the power what y cubed. Differentiating this here with respect to x, I just remain with what? With y cubed there. Then I multiply this by what? By that function that has remained. So multiplying this by y cubed. Can write this out nicely to be 3y cubed, then e to the x, then y to the power 3 like this. Okay, then I also have to find f of y. So for f of y, then I'm going to find, so I do the same thing. So I differentiate with respect the whole thing. So I have 3e to the x, y, then cubed. Then I have to differentiate this part here with respect to what? Y now. I have to do it with respect to y. So I'm going to have, if I differentiate that with respect to y, this would be 3 y squared, then the x there, which is just the same as 3x y squared, writing it like that. Wanting the x to be first, yeah. So meaning I'm multiplying now this by the 3x y squared. Remember, this is how you differentiate when you have an exponential there. So this now, what does this give me? So I see the 3 and the 3 multiply give me a 9. So I have a 9 there. Then I'll have the x come and the y squared. Then I'll have that to be e to the raised to the power x, and I have y to the power 3. Okay, so I've gotten this first order derivatives now. After getting the first order derivatives, so for x, it's here. For y, it's there. Next, what do I need to get? I need to now get, so to get this second order derivatives, so for fxx, so I need to get fxx. So I start with fxx. What does this mean? This means the function which I have already differentiated with respect to x, I should do again, differentiate it with what respect to the x. So in short, I'm getting partial with respect to x of what? Of the function, this one, of function for partial of f. So the partial of x, I mean. So there, meaning you're going to have this as 3. So I get which I found there, 3 y cubed, then e to the x, then I have y cubed there in the bracket. Then so this is what I'm differentiating now respect to what? To x. So keep these values we found here. They're gonna be useful. We come back to them. Okay, so For now, we erase them. Then this here, what does this give me? So when I look at this now, I have to differentiate this with respect to what? Respect to x. So where is my x? My x is there on top. So meaning I'm going to get the same thing that I had here. I differentiate the e to the x. I get the same e to the uh, x the power 3. Differentiate it with respect to the power with respect to x. I remain with what? The y cubed. So the y cubed here is what is multiplying. So multiply this and that there. The powers are going to add. It's the same base. Keep the base, add the powers. 3y, then that's going to be to the power 6. Then you have e to the x, then y to the power 3. So that is for fxx. So I've taken the second order derivative now. So I need to go on further now for y. So I get fyy. So this here means partial of y. The first one, remember which we found? So we have to differentiate that, and that is 9 x y squared e to the xy cubed like this. So now how am I gonna differentiate this one? Oh, easy. So I see that I have y here, but I also have y in the power there. So it means when I'm differentiating this, I have to use product rule. So the product rule here, I differentiate the first one, or the first part of y. So this part here, where there's y, I differentiate this here, I get the power drops, it will be 2, but the 2 that multiplies with that 9 there, which gives me 18. So 18x, and I reduce the power, that is going to be what? To be y there. Then I keep this second part here the way it is. That is going to be x like this, x to the power y over the power 3 like that. Then I'm adding this here. So I'm adding this, and what is this going to be? Now I keep the first part the same, that is 9. The 9x here, y squared is going to remain the same. Then I differentiate the second or I differentiate what is in the power, and what do I get? So here we differentiate what is in the power with respect to what? Respect to y. Respect to y. So you see, first you get e to the what? X cubed to differentiate that. Then this part here, what do you do? Differentiating that, you just get 3xy squared, that is with respect to what? To y. So you get that this will be 3xy squared. I put it there. Okay, then this here is just going to be equal to, write this as 8xy e to the xy cubed. Then I have plus this 3 and the 9 multiply, I have 27. The x and the x there, you keep the base, add the powers. They have 1, so that gives us to the power 2. Y, I do the same, 2, so that gives me to the power 4. Then I have the e to the x to the cubed remain. So this here is my mixed what? Partial. No, this is not my mixed partial, but this is the second order derivative, of course, with respect to what? To y. This is how I will find that. Now, next we need to find the mixed ones. So the mixed ones, so let's find the mixed ones. So in order to find the mixed ones, so you see that we can go first, f of, you have x what? Xy like this. So what does this mean? This means that the function first was differentiated with respect to x, then they are now doing it with what? With respect to y. So this here is going to be partial. You get partial with respect to y like that. Then you're going to have that this here is just going to be, okay, so this here is going to be, of course, this is the first case which we are having there. So this is what you found there as fx was just 3 to the cubed, then e to the x cube like that. So now we take this with respect to y. So with y, you see you have this function and that function. So you have to use product rule yet again. So I differentiate the first part and I keep the second part constant like that. So I have 9, and this here you have, this will be the 3 multiplied by the 3 gives me the 9. Then I reduce the power, that gives me 2. I keep the second part the way it is, which is just e to the y cubed like that. Then I add, now in this case, I'm not differentiating the first part, so I keep the first part the way it is, that is 3y to the power what? To the power 3. I'm going to keep it like that. But then I have to differentiate this. So how? When I differentiate this part here, I just get e to the what? E to the x cubed like that. But then I'm doing it with respect to y. I differentiate what is in the power there. I'm just going to have 3 x, y, then the squared is going to be what to be there from the power. So now cleaning this up, I have 9y squared e to the xy cubed. Then this here, the 3 and the 3 is going to multiply, which gives me a 9. I have x here, so the x will come directly. This and that there, the powers are just going to add, and you have this to the power 5 e to the xy cubed. That's what you get. So this one here, according to Clairaut's theorem, this is telling us when we take this other order, which is f of y x like this, we must get this exact answer here. So I'm going to write it somewhere. So let me write it here, that I keep it. We should compare that we get this answer. So that is e to the x cubed plus, then you have 9x, then y to the 5th, then you have x to the cube like this. So we need to get that answer when we do the other order. So all right, so now what we're saying is we need to get now the reverse one. So when we get f of y and of x like this should give us the same answer as we found before. So this here is just meaning we first found f of y, then we now find the partial with respect to what? To x now. So f of y was just 9, fy was just 9, 9x squared like this, e to the x and cubed. So this is what we had found earlier. So now again, it's because it's x, you have this function and that function, they all have x, so I use product rule again. So in the first one, I differentiate it with respect to x, I remain with y squared. Then this function, I do not differentiate it, I just keep it the way it is, then cubed. Plus the next part here, I keep the first part constant, that is the 9 to the 5. Then y squared. Then I differentiate this part here. So I get e to the x cubed. Then I differentiate x here with respect to, the power with respect to x, I get x cubed remain. So then this is just going to be 9 squared e to the x y cubed. Then I have plus 9x. Then you see 2 and 3 gives me 5. So the power 5 e to the xy cubed there. Okay, so this here is going to be my answer. And this here is equal to this, which then confirms that Clairaut's theorem, which we earlier were asked, or we earlier stated that we have to prove, because it's saying here, show that the mixed partial derivatives are equal. And from this here, we see that they are equal. Well, if you are new, remember to hit the subscribe button, and I'm gonna see you in the next one.